Welcome to this class. Today I am continuing the chapter Wave of the subject Science and Technology of class 10, and this Wave chapter is taken in the unit number 10. We have divided this unit into 11 different parts and we are presenting each of them one after another. This is 10th part of the chapter Wave, and today we are going to focus on defect of vision and its correction. Defect of vision means eye defect, and how to correct the eye defect. We are talking about this eye defect in detail. Okay, before this I want to give one example. If someone says look at this and something is placed very close to your eye, then you will push it away because you are not able to see this object clearly at this position. You will push it away and then you will see the object, what is it and what is written here, isn't it? Have you noticed this? We cannot see an object clearly at this place, but if it is taken to certain distance, then we will be able to see that object clearly. It means an object can be seen clearly at certain distance when it is taken near to your eye. This is called near point. That's why I want to start this class with near point and far point. Okay, what is near point? We can say this way: the nearest distance from our eye at which an object can be seen clearly without any stress on the eye is called near point of eye. Isn't it? Without any stress, in relaxed condition, at which distance the object can be seen clearly, that distance from the eye is called near point of eye. And near point of normal eye means healthy eye, lies at a distance of 25 centimeter. What it mean? If an object is placed at 25 centimeter distance, then we'll be able to see this clearly without any stress on our eye. That's why we can say that near point lies at a distance of 25 centimeter. Okay, let's talk about the far point also. All of we know that we can see the star also clearly. A star can also be seen clearly. It is very far away, millions of kilometers away from our eye. It cannot be measured in kilometer, and another unit is developed, that is light year. The distance of a star is measured in light year, isn't it? That can also be seen clearly. That's why, what is far point of our eye? Far point of our eye means the farthest point from our eye at which an object can be seen clearly is called far point of our eye. And far point of normal eye lies at infinity. For normal eye, healthy eye, we will be able to see the star also. It means the far point lies at infinity. Okay, I told you about 2 points: near point, far point. Near point lies at the distance of 25 centimeter. I am talking about the normal eye, healthy eye. And far point lies at the distance of what? Infinity. Some person cannot see star clearly, that's defective eye. There is eye defect. Some person cannot see an object at the distance of 25 centimeter. You will be able to see the object nearer than 25 centimeter only. When placed nearer than 25 centimeter, then only you will be able to see the object clearly. This is the defective eye. Okay, now let's talk about the near object and distant object. How near object is focused on the retina and how distant object is also focused on the retina by our eye. Okay, have a diagram. This diagram represents the focusing of near object on the retina. The light rays coming from the near object is represented by diverging ray, and wherever we have to make image of an object, then at least 2 rays of light should be drawn from that object. Here we have 2 rays of light drawn from the object, and when it is conversed by this convex lens, it has to be focused on the retina, otherwise we will not be able to see this near object. For this ciliary muscle contracts and it makes the convex lens of eye thick, and thick lens has high power, and this high power lens converges the ray of light on the retina. Converging capacity is more with high power lens and the object is focused on the retina. It means, what it means? If you want to see the line on your palm this way, you will be able to see this clearly, isn't it? But at this time, what is happening to your eye? The ciliary muscle contracts and convex lens of eye becomes thick, and thick lens has greater power, and it converges the diverging ray of light coming from this line. Converges the diverging ray of light coming from this line at greater angle, with greater angle, like this converging capacity is more, and then it is focused on the retina. Then only we will be able to see the object clearly. It means, while watching near object, convex lens of eye should be thick, converging capacity should be more. And what about the distant object? Look at this. The distant object, the light ray coming from the distant object is represented by parallel ray. Here we have parallel ray. It is coming from the object. The parallel ray of light coming from the object is focused on the retina again. How it is possible? Because at this time, ciliary muscle relaxes and convex lens becomes thin, and thin convex lens has less converging capacity. Look at this, represented by red angle shown in red line. Here it is more, here it is less, converging capacity is less. That's why distant object can be focused on the retina. It means, what is the conclusion of this diagram? If you want to see something a little far away, there is a tree, there is a building, and there are windows in the building, yeah, then what happens? Your convex lens of eye becomes thinner automatically because of the action of the ciliary muscle. Ciliary muscle relaxes and convex lens becomes thinner, and this thin convex lens has less converging capacity. Look at this, less converging capacity is shown here, and because of less converging capacity, distant object can also be focused on the retina. Very interesting. While watching near object, convex lens should be thick. While watching distant object, convex lens should be thin, and automatically all these are adjusted by ciliary muscle. Then why we have defect in eye? Why sometimes some person cannot see near object clearly, some person cannot see distant object clearly? It's very simple, clear, that if the convex lens of eye cannot change its thickness according to the requirement, then we will have eye defect. While watching near object, if convex lens cannot be thick, while watching distant object, if convex lens cannot be thin, then we will have defect of vision. So, defect of vision can be expressed this way shortly: when the convex lens of eye cannot change its thickness according to the requirement, then either the near object or the distant object cannot be seen clearly, and it is known as eye defect. Very simple, very clear, isn't it? Okay, now there are different types of eye defect, but the common eye defect is of two types. Those persons who are wearing spectacle, either they have this short-sightedness, which is also called myopia, or they might have long-sightedness or hypermetropia. Normal eye defect is either short-sightedness or long-sightedness. Now we will talk in detail about each of these defects. Yes? Okay, let's talk about myopia or short-sightedness. What is it? If a man can see near object clearly but distant object cannot be seen clearly, then this defect is called myopia. Near objects can be seen clearly but distant object cannot be seen clearly. If he want to read something and he can read only at the distance of 20 centimeter or 15 centimeter, then his near point came towards the eye. It means he can see near object clearly, distant object cannot be seen clearly. This is called myopia. It is an eye defect in which only near objects can be seen clearly but distant object cannot be seen clearly. This myopia can be represented diagrammatically like this. In this case, near object can be seen clearly. This is not the problem because the convex lens of eye is thick and cannot be thin according to the requirement. This diagram represents this defect. The light ray coming from distant objects are not focused on the retina. It is focused in front of the retina. Distant object cannot be seen. But in this defect, the light ray coming from the near object can be seen. Look at this, light ray coming from the near object is focused on the retina. Near object can be seen, distant object cannot be seen. This is the diagrammatic representation of what? Myopia or short-sightedness. It's very simple, clear. Okay. Now let's have a little more about the same myopia. Let's take it to one of the side. Now I want to tell you different characteristics of myopia. Certain characteristic related to myopia. If you are told to write characteristic or you are told to say the characteristic of myopia, you can say that in this defect only near objects can be seen clearly but distant objects cannot be seen clearly, isn't it? Now next, in this defect convex lens of eye becomes thicker, focal length becomes shorter. Convex lens if becomes thicker, then certainly focal length becomes more. It was taught in previous class. In the power of lens, we are taught that if a convex lens is thicker in the middle more than another, then its converging capacity is more. In this defect, convex lens of eye becomes thicker. It means if lens is thick, then focal length becomes short. We know about this previously, it was told, and power will be high. In this defect, the lens becomes thick, power becomes high, focal length becomes short. The focal length of normal convex lens of eye is 2 centimeter, 20 millimeter. If it becomes thicker, then focal length will be less than 2 centimeter, maybe 1.8, 1.5, 1.6, isn't it? Okay. Now another characteristic we can say that in this defect, distant objects are focused in front of the retina. This distant object cannot be seen clearly, told previously in first point. If it is not seen clearly, then where its image forms, I mean to say where the image of distant object forms, it forms in front of the retina, not on the retina. In this defect, the distant objects are focused in front of the retina. Now another characteristic we can say, in this defect, eyeball becomes elongated, due to which distance between lens and retina increases. What it mean? This is normal eyeball. Because of certain health problem, health of eye, because of the certain problem related to medicine, if eyeball is not normal, it is somewhat elongated like this. Elongated eyeball, this is the elongated eyeball, and it is somewhat oval. If eyeball becomes elongated, then certainly distance between lens and retina increases. And in this case, in myopia, normally the distance between lens and retina increases due to the elongated eyeball. This is the health problem of eye, isn't it? Eye health. Okay, these are the important characteristic of myopia. What is it? Near object can be seen clearly, distant object cannot be seen clearly, isn't it? And another is, lens is thick, power is more, focal length is short. Another one is distant objects are focused in front of the retina. Another one is the elongated eyeball. These are the major characteristics of short-sightedness. Now exactly what is the reason of short-sightedness? Why some people have eye defect short-sightedness. Some people, they do not have. What exactly is the reason? In science, what is told, short-sightedness occurs either due to the shortening of the focal length of the convex lens of eye. Shortening of the focal length of the convex lens of eye means what? Convex lens is being thick and focal length is being short, and if it happens to our eye, then we will have myopia or short-sightedness. This is one of the great reasons. Another reason may be due to the elongated eyeball, which was shown just before this. Due to elongated eyeball, which increases the distance between lens and retina. If eyeball is a little elongated, then the distance between lens and retina increases and image doesn't fall on the retina, it falls in front of the retina. This way, either due to the shortening of the focal length of the convex lens or due to the elongation of the eyeball, this myopia may occur. These are the two basic reasons of myopia. Now the time came to talk about the correction. How to correct this defect? How can we correct myopia? Look at this. This is myopia. Yes, we don't have to show this. At this time, I'm not showing this light coming from the near object because near object can be seen clearly. The major defect is what? Distant object is not focused on the retina, not seen clearly. Now, how to remove this defect? Now, I want to show with animated diagram. Look at this. This can be corrected by using concave lens. Remember this. Myopia is corrected by using what? Concave lens. How? Why? Now, the reason is coming with the help of diagram. I want to tell you first diagram and then a little explanation. In this case, means if light is coming from the distant object, then they are parallel to each other. Before the lens of eye, it has to enter through concave lens of spectacle. This concave lens is used in spectacle. Concave lens diverges the rays of light. We know about this. First, it diverges a little. The rays of light is diverged a little first by the concave lens of spectacle. And then it reaches to the convex lens of eye. Now, eye has to converge it on the retina. Is it possible? Yes. If it is coming this way parallel to each other, then angle of convergence will be more. But if it is coming diverging ray, I mean to say diverging ray comes with the same angle of convergence, it will be converged behind the previous converging point. So, image falls on the retina. Yes, previously only one convex lens converges the ray of light, its power is high, and that's why converge in front of the retina. But now, not parallel ray of light is entering into the eye lens. Diverging ray is entering, and with the same angle of convergence, it can be focused on the retina. So, a suitable power of concave lens should be used to correct myopia. Now, let's talk about this. If we have to write somewhere, you can say this way. In short-sightedness or myopia, distant objects are focused in front of the retina as shown in the diagram. Look at this diagram is here, and first line what I told you, in front of the retina the distant objects are focused. But when concave lens is used in spectacle this way, then the parallel ray coming from the distant objects are first diverged by this concave lens, and then convex lens of the eye converges these rays. So, the focusing point moves backward and image forms on the retina. Focusing point was this in previous class. Now, it moved backward and the image is focused on the retina, image forms on the retina. Therefore, concave lens is used to correct short-sightedness. This is the reason why we are using concave lens. Clear? This is all about the myopia, characteristic of myopia, reason of myopia and correction of myopia. Now, let's talk about another defect, hypermetropia or long-sightedness. Looking at the word long, just remember this long means distant. Distant object can be seen clearly, near object cannot be seen clearly. This is the definition of long-sightedness. This is an eye defect in which only distant objects can be seen clearly, just opposite of the myopia, seen clearly, but near objects cannot be seen clearly. This is hypermetropia or long-sightedness. Now this is eye, and if the rays of light are coming from distant object, then they can be focused on the retina. You can understand easily that the lens is thin. That's why thin lens is necessary to focus the distant object on the retina, and we have thin lens in eye. That's why distant objects are focused on the retina. But what about near object? Look at the near object. Diverging ray comes from near object and it is not focused on the retina. The reason is very simple. Eye lens is thin, so its capacity, converging capacity is less, and so image falls behind the retina. Image forms behind the retina. It's clear or not? This is the diagrammatic representation of hypermetropia or long-sightedness. If you are told to draw a diagram to show hypermetropia, you can draw this diagram. Now let's talk about the reason. What is the reason of hypermetropia or long-sightedness? The reason is either it occurs due to the elongation of the focal length of the convex lens of eye, elongation of the focal length, increase of the focal length of the convex lens of eye. It means lens is being thin and focal length is being long, and that's why the near object cannot be focused on the retina, behind it goes behind. Okay. Now second reason may be due to the bulging of eyeball, which decreases distance between lens and retina, or both may occur in the same eye, isn't it? This bulging of eyeball means what? If eyeball is not normal, it is somewhat like this. Look at this, is called bulged eyeball. It's gone up and down. Yes, not normal. Up and down the distance is more. It means the distance between lens and retina is less, isn't it? This distance is less. In normal eyeball, it is a little long, but in bulged eyeball, it is less. In elongated eyeball, it is greater than normal eyeball. Okay, let's come back. Due to bulging of eyeball, bulging means this, isn't it? Which decreases the distance between the lens and retina. Either due to this or both may be the cause of what? Hypermetropia or long-sightedness. Okay, now let's come back to the same. This is the diagrammatic representation, and the definition is given, what is hypermetropia. Now I want to take it to one side and let's talk about its characteristic. If you are told to write the characteristic, or if you are told to say the characteristic of long-sightedness, very simple: long, distant. Distant object can be seen clearly. In this defect, distant object can be seen clearly, but near objects cannot be seen clearly. This is first prime characteristic, isn't it? Now second, in this defect, near objects are focused behind the retina. Distant object can be seen, near objects are focused behind the retina, as I discussed about this. Yeah. And another, in this defect, convex lens of eye becomes thin. Not normal, this convex lens becomes thin, and power will be less. Thin lens has less power. We have learned this in the power of lens. And focal length will be long. If power is less, focal length is more, isn't it? And focal length becomes long. If power is more, then focal length will be less. In this case, focal length is more. This is another characteristic of long-sightedness. Now next, in this defect, eyeball will be bulged, due to which the distance between lens and retina decreases. And this is the diagram which I made in previous slide also. Look at this. The distance between lens and retina is short, isn't it? Okay, instead of falling image on the retina, now it goes back because this distance is short. These are the characteristics related to what? Hypermetropia or long-sightedness. Okay, after the characteristic of this hypermetropia, now we have to go through correction. This is the eye defect in which distant object can be seen, near object cannot be seen. Now how to correct, how to make him clear in near object also. Look at this. This is the defect. Yeah, the distant object is focused on the retina, but near object is focused behind the retina. Now how to solve this problem, how to remove this defect? Now I want to show with the animated diagram. This is a convex lens. We are using convex lens in the spectacle to correct this defect. Remember this. Myopia is corrected by using concave lens in the spectacle, but this is hypermetropia, just opposite of the concave lens, convex lens, which converges the ray of light. Convex lens is used. Okay, now how it works? Let's talk about this working. How it is possible to focus near object on the retina, is behind the retina. The light ray coming from the near object is first converged by the convex lens of spectacle, and then only it goes to convex lens of eye, and then convex lens of eye converges it on the retina. Here we have two convex lenses. If only one convex lens of eye is involved, then the image falls behind the retina. But when convex lens is used in spectacle, now two convex lenses are converging the rays of light coming from near object. That's why converging point moves towards the retina, not at the back of the retina. It moves towards the retina and the image falls on the retina. That's why we have to use this convex lens in this case. Okay, we can write shortly, or we can explain shortly about this way. In long-sightedness, near objects are focused behind the retina, as shown in the diagram. Here it is, isn't it? But when a convex lens is used in the spectacles, then the diverging rays coming from the near object are not converged only by the convex lens of our eye, but converged by the convex lens of spectacle also. At this time converged by convex lens of eye, but at this time converged by the convex lens of spectacle also, isn't it? So the focusing point, which was this in previous case in defect, so the focusing point move towards the retina and image falls on the retina. Focusing point move towards retina this way and image falls on the retina. Then near object can also be seen clearly as shown in this diagram. Yes, it's very simple, clear if we understand this in sequential way. I mean to say, in sequence you have to remember this. Okay, this is the correction of hypermetropia. Why don't we compare short-sightedness and long-sightedness? We have done everything about these two, their characteristic, their correction, etc. Let's bring them together. Myopia, hypermetropia, we can differentiate with different points. Myopia, in this defect only near objects can be seen clearly, but distant objects cannot be seen clearly. But in this defect, distant object can be seen clearly, but near object cannot be seen clearly, just opposite. Yes, don't be confused. Sometimes students are confused. Instead of myopia, they will write hypermetropia. Characteristic can be reversed. But we have to be clear. Myopia, spelling is short. You can remember short. Shortly, this near object can be seen clearly. The spelling is long. That's why distant object can be seen clearly. This way also you can remember. Okay, next. In this defect, the distant objects are focused in front of the retina. Yes, but in this defect, near objects are focused behind the retina. And all these are done. I am just comparing. This is the revision. In this defect, convex lens of eye becomes thicker, focal length becomes shorter, and power will be high. If lens is thick, focal length becomes short and power becomes high. Here, it is in this defect, convex lens of eye becomes thinner, power will be less, and focal length just opposite. Yes. Now next, in this defect, eyeball become elongated, means it is somewhat oval, and distance between lens and retina increases. It was told, and we are talking the difference only. In this defect, eyeball will be bulged, due to which the distance between lens and retina decreases. This defect is corrected by using concave lens. In this defect is corrected by using convex lens in spectacle. After all this, why don't we evaluate ourselves by using brainstorming type of question? Look at this. I made a question. Study this question in detail and try to find the correct option. A person suffering with myopia can see only near objects clearly, but distant objects cannot be seen clearly because the power of convex lens of their eye is high. Is it? Just think about this. I want to add one argument for this. They have to wear convex lens to see the distant object clearly. Just think about this. You have few seconds. This is one argument, whether this argument is correct or not. And argument 2, in this defect, distant objects are focused in front of the retina. Yes or no? Just think about this. And we have to select one of the option from this. Now, let's verify each of the option with reason. Only statement is correct. What is seen here? A person suffering with myopia can see only near object clearly, but distant object cannot be seen clearly because of the power of convex lens of eye is high. Why don't we have the same diagram? Look at this is myopia, isn't it? Distant object, what is written here? Myopia can see only near object. Yes, only near object can be seen clearly. But distant object cannot be seen clearly. Yes, distant object cannot be seen clearly because the power of the convex lens of their eye is high. Power is high, that's why focus in front of the retina. Yes, so this statement is correct. Yes, now I want to remove this diagram. But here look at this, only statement is correct is written. Maybe argument 1 or 2 correct. That's why this option is suspended, may be correct, may not be correct. Later we'll come back to this. But let's go to second. Statement and argument 1 is correct. Statement is correct, we know. Argument 1, they have to wear convex lens to see the distant object clearly. Is it? Let's have the correction. We corrected like this, isn't it? Previously I taught like this. Here concave lens is used. How to use convex lens? This is not correct. The argument 1 is incorrect. That's why we have to drop it. This option number 2 is dropped. It is incorrect option. Okay. Till now 1 exists but 2 is incorrect. Number 3. Only argument 2 is correct. Looking at this is incorrect because only, how can we say only, because the statement is also correct. Even though, let's check argument 2. In this defect, distant objects are focused in front of the retina. Is it? Now, I want to bring the diagram back. What is written? Distant objects are focused in front of the retina. This is distant. Light rays are coming from distant object. It is focused in front of the retina. Yes, this argument 2 is correct. It means statement and argument 2 are correct. This option is correct. So we have to take it. This way we can find the correct answer, correct option. I think I finished everything related to short-sightedness and long-sightedness of class 10. What are the characteristics, their correction and reason of use of convex and concave lens, etc. Now, I want to stop this class. In another class, we'll talk about the defect of eye other than this short-sighted and long-sightedness. Other defects also there with eye, which we will discuss in another class. Okay, now I want to stop. Thank you.